Hi everybody, today I want to talk to you about everyone's favorite, the TCA cycle, also known as the Krebs cycle or the citric acid cycle. I can hear the groans from here. I don't think it's going to be that bad. I've broken it down into 8 steps and you might actually find it interesting, dare I say that. You can always let me know after the lecture how you really feel. Let's talk about the TCA cycle just in general concepts to begin with. It produces a lot more ATP compared to glycolysis, which I'm not sure if that's saying that much because we only get 2 net ATP from glycolysis, as you'll recall. It takes place in the mitochondria as opposed to the cytosol where glycolysis takes place. And there are 8 major steps, so it's a bit more obviously complicated than glycolysis. Acetyl-CoA, which we know is produced once pyruvate is oxidized, is utilized primarily in the citric acid cycle. And there's a number of redox reactions where energy is harvested and ATP molecules or energy molecules are produced, which is what we want because that's the end game of the TCA cycle. That's the whole point. And electron carriers such as NAD and FADH2 pass electrons in the electron transport chain, ultimately generating ATP and cellular respiration is what we get in the end. So let's begin with the first 4 steps. And I really don't want to read these to you. I just think it helps me at least to think about the TCA cycle in a step-by-step process. And I have a diagram, also a visualization, which is always good for me as well, to actually depict these 8 steps that I'm going to go over with you. So we start with acetyl-CoA, and it essentially combines. It's a 4-carbon. It combines with a 4-carbon acceptor oxaloacetate, and you get the formation of citrate, which is a 6-carbon sugar. 4 and 2 is 6. And that citrate is converted in the next step to isocitrate. And it's a 2-step process, so I've simplified it. You have the removal and then the addition of water, a water molecule, H2O. Following that, the isocitrate that we've just produced is oxidized and you have more carbon dioxide being released and alpha ketoglutarate is formed. And there is a reduction reaction which occurs. NAD plus is reduced to NADH. And there's an enzyme called isocitrate dehydrogenase which catalyzes that reaction and regulates the speed of the entire TCA cycle. So it's a major enzyme. You want to probably remember that. Isocitrate dehydrogenase. Next, in the 4th step, so we're almost halfway there, or we are halfway there, the alpha ketoglutarate that we just produced is oxidized. And once again, we have a reduction reaction, NAD to NADH, and we have more release, or the release of more, I guess I should say, carbon dioxide. And alpha ketoglutarate picks up coenzyme A and forms this unstable molecule called succinyl-CoA. And once again, we have an enzyme catalyzing that reaction, alpha ketoglutarate dehydrogenase. It's not really a stretch of the imagination. The molecule that we're oxidizing is called alpha ketoglutarate, and the enzyme that catalyzes the reaction is alpha ketoglutarate. Makes it easier to memorize, but it's not terribly creative. So steps 5 through 8, step number 5, the CoA of the succinyl-CoA is actually replaced by a phosphate group. And the purpose of that is to make ATP. So we have a transfer of a phosphate group onto that ADP molecule to make ATP, which of course means there's 3 phosphate molecules. And that ultimately results in the production of succinate. Once succinate is oxidized, fumarate is formed. And during that reaction, there's 2 hydrogen atoms and their electrons, of course, that are transferred to FAD, making it FADH2. Note the pink arrow. That's my attempt at getting a little creative with my presentation. In step 7, water is added to that fumarate molecule that we just formed in step 6, and ultimately we end up with malate. Oxaloacetate, which is of course what we started with, that 4-carbon molecule that we added the 2-carbon molecule acetyl-CoA to, is regenerated by oxidation of malate. And we get another reduction reaction of NAD to NADH. So I've simplified it quite a bit, but if you really break it down into these 8 steps and look at each one, and then look at a corresponding visualization of the 8 steps, I think it really helps to process what the TCA cycle is and what it does. And it's not quite so anxiety inducing, in my opinion, and it makes it much easier to understand. So what do we get ultimately? What are the products of TCA? If we're going to think about that, we need to think about what happens in a single turn of the TCA cycle. So if we have one molecule of acetyl-CoA that goes through the cycle, 2 carbons, right? Acetyl-CoA has 2 carbons entering the cycle. We get the release of 2 carbon dioxide molecules. We get 3 molecules of NADH and 1 molecule of FADH. And we get 1 ATP. But you got to remember that glucose ultimately produces 2 acetyl-CoA. So multiply all those by 2. And, it doesn't produce a lot of ATP, but that's why we can make ATP indirectly, by way of NADH and FADH too. I've got a picture of the 8 steps that I've just reviewed. So take some time to look at that and actually go through each step that I've talked about. And again, I think it helps to visualize what I've talked about. Take each step, walk through the process, become familiar with it. I'm sure most of you have had this multiple times throughout your academic career. It's just if you don't use it every day, we tend to lose it. I mean, it's not something that I think that you're probably discussing or texting about. I'm not, at least. And this table shows you through each process how many ATP are produced and what the ultimate yield, the ultimate net is of the ATP. Glycolysis, we get 2 ATP. Through pyruvate oxidation, it breaks it down for you with the 5 ATP. And then remember I mentioned the NADH and FADH actually help us with that ATP accrual, and the actual citric acid cycle itself, which we just talked about how many ATP are produced, and you get a net of 30 to 32 depending on how you add those up. Let me know if you have any questions. It's complex material, and I'll say it again, I sound like a broken record. If you break it down step by step and process it that way, you'll have a lot easier time with it. Please let me know if you have any questions. Take care.